So what I'm going over is a model of motor inhibition for a complex skill, so the baseball swing, covered by Rob Gray in his paper. So to begin with, the first image is the ability to stop an ongoing action based on environmental cues is vital in complex skills like baseball batting, of course, that it mentions in the paper. In this model of motor inhibition, the batter makes 4 key judgments about the pitch's trajectory at different moments as the ball approaches. These judgments can trigger 3 stop signals, each occurring at a specific point in time. The batter's final swing outcome depends on which stop signal is activated. So the first one is the inhibited swing. The batter starts but stops early. The bat never reaches the plate. The second one is the partial swing. The swing is more advanced but still doesn't cross the plate. Third is the interrupted swing. The bat crosses the plate but shows a clear attempt to stop. And the full swing is no inhibition occurs. The swing is fully completed. This model explains how expert batters integrate visual information and motor control to make a split-second decision, allowing them to adapt fluidly to unpredictable pitches.
Which a batter's swing can be halted are governed by the presence of stop signals. If a stop signal is perceived by the batter, they may choose to halt their swing in the process, potentially saving them from a strike call by the umpire. Depending on when that stop signal is perceived, a different level of reaction, and thus a different swing, can be observed. For example, if a pitched ball looks like a bad pitch only just in front of the plate, the batter is likely to respond with a full swing because they did not have enough time to change their response. If the ball looks badly thrown early after leaving the pitcher's hand, though, the batter may exhibit an inhibited swing, partial swing, or simply not swing at all. The concept of stop signals has further application in all walks of life, as according to Frederick Verbruggen in his article Response Inhibition in the Stop Signal Paradigm, understanding stop signals is imperative for understanding how people can readily stop talking, walking, typing, and so on in response to changes in internal states or changes in their environment.
The article I chose to reference is called A Coordinative Structure in Baseball Hitting. It talks about what happens when coordination and timing for a movement, such as a baseball swing. To help us understand movement coordination, we need to look at 2 viewpoints for a perceptual motor process. The 2 viewpoints are the coordination across the activities of body segments and the coordination of limb movements with respect to an environment. A coordinative structure in a motor performance involves managing the body's degree of freedom. Internal coordination refers to organizing different body segments to function together as a single task, specific unit, also known as a coordinative structure. Also, there's environmental coordination. This focuses on adjusting movements in response to environmental changes. This allows for the ability to adapt during the task. We see both internal coordination and environmental coordination in the full swing video. As you can see, Austin has to organize all parts of his body to complete the specific task of hitting the ball. He also had to adjust to the environmental factor of wind in order to adapt and hit the ball. As you can see, coordination allows for movement to remain stable and functional even when disturbed.
In the paper by Xian Hu and Chen Chan titled Neural Processes of the Preparatory Control for Stop Signal Inhibition, it looked into where in the brain motor preparation occurs. The research shows that in the extent of preparatory inhibition and the execution were negatively correlated across the subjects. This shows a relationship between the mutual inhibition and the go and stop processes that occurs in the brain. It was also shown that individuals with a short stop signal reaction time showed greater activation in the right orbital frontal cortex. Within this, with this greater activation, is hypothesized that there is a superior connection to attention and inhibitory control during the prep phase of a swing or any other inhibition task.
Another Rob Gray paper titled Integrating Visual Trajectory and Probabilistic Information in Baseball Batting simulated similar experiments to what we discussed in class. This paper was about visual trajectory information and how it can guide motor behavior when swinging a baseball. It concluded that batters were able to adjust based on altering visual information about the flight of the ball, such as throwing a curveball, changeup, or a fastball. The graph shows that the fastball is easier to react to compared to the other throws because there is a quicker initiation time, as the time to contact info or just swinging the bat was a lot easier to perceive perceive/anticipate the timing as the direction does not change by any dramatic. How might the role of anticipation and prediction affect a player's ability to inhibit a swing?